This is the Windows Azure portal. Let me log in. In this video, we'll show you how to create a Windows Azure HDInsight cluster and run some of the samples that are included. Once you're logged in, at the bottom of the page, click on New and then Data Services, HDInsight. If your account is not enabled for this preview service feature, it will be grayed out. And when you click on the grayed out feature, it will take you to a preview features sign up page, and please note this may take up to a few days to get approved. In order to get an HDInsight cluster running, you will first need to create a storage account. This will be used by HDInsight Cluster for storing configuration, and also it will be the default file system. Create a name and make sure you select East US. For this preview, all HDInsight clusters will be created in the East US data center. Also important to uncheck the Enable Geo-replication. Now we're ready to create an HDInsight cluster. Click on New, HDInsight, and click Create. You'll need to enter a name and a very strong password, and of course you want to make sure that you select the right storage account key. Once you hit the Create HDInsight Cluster button, it will take up to 5 to 10 minutes to get the cluster created. You may monitor the cluster creation process by going to the HDInsight tab. And it will go through several different steps. First is that it will be accepted for provisioning, and then it will be provisioning the storage system, and then configuring the Azure VM, and finally configuring the actual Windows Azure HDInsight cluster. So this process, once again, may take up to a few minutes to complete. Once the cluster has been provisioned, you'll need to log into its own management portal. The management portal has a very simple design. Enter login and password. The default is admin and the password that you used previously. And in the management portal console, we will look at the samples area first. There are 5 samples that's included with HDInsight cluster. The simplest one is the classic calculate pi example. It runs a Monte Carlo simulation that maps out the calculation in parallel. Click on deploy and accept the default. Please note that the UI is designed to help you to construct a final command line to run. To check your result, you will need to go to the history page. In the job history panel, as you can see, the MapReduce job has completed for the pi example, and as you can see, it gave a very accurate result. At the detailed output page, it shows you the exact steps of the actual MapReduce process that happened. Monitoring page shows you the detailed statistics for the MapReduce metrics, number of mappers and reducers. And of course, if you're running multiple jobs, there's the MapReduce queues. It also shows you the average of different time period. It allows you to also take a look at the health of the name node and other machines in the cluster. If you're an advanced user, you can remote desktop into the head node of the cluster. It will give you a raw Hadoop environment. Let's run a simple example in the interactive console. In this example, I need to upload a JavaScript that does the MapReduce and also the data file from the Gutenberg repository. It's simply a text of the Da Vinci book. So once I have done both, I need to paste in a pig script that allows me to run a MapReduce and find out the top 10 words that are in the document. The first thing I need to change here is the default directory. The default directory for a user is in /user and your username. In this case, it's user/admin. You also want to make sure that the MapReduce script can be found by the pig script. We'll add a schema, and then we want to save that into the HDFS. So once I hit run, the process will be running in the background, and it will also produce a log file which you can take a look and monitor as the MapReduce processes progress. Click on the View Log link, and it will take you to a live log page, and it will give you a progress update of the MapReduce job. Looks like we're about 20% done, and the entire process will take approximately 2 minutes to complete. And once the process is complete, we'll take a look at the results back in the JavaScript console. Click on the Browser tab in the Interactive Console. The ~ls is a HDFS command. It lists the content in your current directory. Looks like DaVinci Top 10 Words has been created as a result. The next step is to read in the data and analyze it with our basic JavaScript plotting tools. fs.read reads in the data set into a file object, and then we can parse the data into a JSON format by giving it a simple schema, word, and the count as a long integer. Once that has been parsed, we can use the graph object to do a plot of the actual results, and you can also use a pie chart. If you would like to try the samples yourself, let me show you where to find the complete instructions and data files. It's under the samples page and under the word count example. Thank you for watching this video. I hope you find it useful.